Okay, so example one, graph the function f of x equals negative 3 to the x on the axis below. You must plot the asymptote and any 2 points with whole number coordinates. Now, what I did here was I took this question right off of Delta Math. So you're going to have to click this box and you're going to have to choose horizontal or vertical asymptote. But because we're dealing with exponential functions, it's always going to be a horizontal asymptote. Now, as soon as you do that, it's going to put a dotted line on the bottom and you'll have to click and drag it up and down. And then it's going to connect these two yellow dots, which are not part of my function right now. I'm going to have to move them in just a second. But it's a static problem that I'm using right here where Delta Math, you'll be able to be, it's a bit more interactive. All right, so what do I know about this function, 3 to the x? First of all, this is the graph of 3 to the x reflected over the x-axis. That's what that negative does. Remember, if you take something like negative 3 squared, the answer is negative 9. You must do the exponent first before the negation. I know it seems strange, it's weird, it's different than negative 3 squared, which would come out to be 9. So that's why this is the graph of 3 to the x with a negative in front of it, which reflects it over the x-axis. So what do we know about 3 to the x? Well, its y-intercept would be 1. So therefore, reflect that over the x-axis. I'm going to have a y-intercept down here. I need some points on this. So for example, I could say 3 to the first would be 3. But if we reflect that over the x-axis, that's going to be negative 3. So 1, 2, 3. And then we could do this. We could go 3 squared is 9. So 3 to the second would be 9. Negated would be negative 9. So we could put that down here. These are the only 3 points on this graph with whole number coordinates. So I need at least 2 of those. All right. And so now what I want to do is connect it. I'm going to go ahead and let's do it this way. I'm going to put my horizontal asymptote on the x-axis, denoted by a broken line. And then graph my exponential function. They are tricky to draw. A couple things you do want to be very careful of. One is do not go vertical. Otherwise, you fail the vertical line test and you have problems. Second, this is a little off here maybe. You try to avoid going completely horizontal. It's harder on this tablet to draw a nice smooth graph. And plus on Delta Math, it's going to fill it all in for you as long as you put the points in the right spot. Okay. All right, example 2, graph the function f of x equals negative 2 times 1/3 to the x plus 1 on the graph below. You must plot the asymptote at any 2 points with whole number coordinates. So again, we know we're going to have a horizontal asymptote because we're dealing with exponential functions. By the way, the only time you have vertical would be what we call logarithmic functions, which you guys have talked about in years past or last year in particular, but we're going to talk about more next week. All right, so what do we have here? So f of x equals negative 2 times 1/3 to the x plus 1. All right, so in terms of our transformations, this would be the graph of 1/3 to the x, shifted left 1. And again, just remember, it's the order in which you would do these operations. So if you're plugging a number in for x, plugging in 1 or 2 or 3, then you would go ahead and add 1 first. Then you would multiply either by 2 or by negative 1 at either or. Because again, they do 2 separate things. So it's going to be shifted left 1 because of the x plus 1. I'm going to say reflected over the x-axis. And then stretched vertically by 2. Okay. All right, so let's talk about the asymptote. Let's talk about everything else here. So first of all, the asymptote is going to be Well, because there's no vertical shifting of the graph, my asymptote is still going to be the x-axis. All right. Now, my y-intercept, normally if I plug in 0, 0 plus 1 is 1. 1/3 to the 1 is going to be 1/3 times -2 is not going to be a whole number. So we're not going to be able to use the y-intercept here to graph it. Now, in terms of numbers, what should we plug in? Well, notice if I plug in any positive numbers, we're going to get some sort of third or 1/9 or whatever, which is not going to be a whole number. So I've got to use x equals start with -1. So f of -1 is -2, 1/3 times -1 plus 1. -1 plus 1 is 0. 1/3 to the 0 is 1 times -2 is -2. So we get the point -1, -2. And then if I do f of -2, I get 1/3 to the -1 power. Now remember, a negative exponent just reciprocates this. So the negative will reciprocate. To the first power would just mean that this is 3. So I get -6. So -2, -6. Let's go ahead and graph this. Again, avoid, if you can, avoid going completely vertical. That's a terrible graph. Let me try that again. I'm going to actually start from this end and go down. It's a little better. And then just again, try to avoid going horizontal. It should just get closer and closer to the x-axis. All right. Try one more example, example 3. Now this one here looks very cluttered on the screen. I was trying to take the Delta Math question and put it into this PDF into the guided notes for you. So these are all menu options for the most part. So it says, what are the features of the function 2 to the x minus 3 graph below? So here they are here. So it says the function is, and they want to know, is it logarithmic or exponential? Well, it's exponential. Again, how do I know that? Two reasons, really. One is I have a variable exponent. That's right there, makes it exponential. And two, it's not logarithmic because we don't see the log part that you'll see next week. All right. Because it's exponential, we have a horizontal asymptote of, well, again, this is the graph of 2 to the x shifted down 3. So 2 to the x would have a horizontal asymptote of the x-axis, y equals 0. This is going to have a horizontal asymptote of, I'm just going to write over this, y equals, and you'd have to plug in -3. The range of the function, well, again, the range, generally speaking, of 2 to the x, okay, the range is 0 to infinity. But if we're shifting the entire graph down 3, then the range is going to be -3 to infinity. And it is because the base is greater than 1, it's increasing on its domain of all real numbers. The end behavior on the left side is as, well, let's see here again, the end behavior talks about as x goes to an infinity. So here it says x goes to -infinity. Look at this. The function is getting closer and closer and closer to -3. And the end behavior on the right side is as x goes to infinity. Look at this function. Now this function is going towards positive infinity. Okay, so like I said, these are all going to be drop-down menus. We just have to make the selections and go from there. All right, I'm going to pause and continue in the next video.